arrange the following in increasing order of basicity. You have been given three compounds A, B and C, and all are amines, right? And you can see this nitrogen in all the three compounds carries lone pair on it, right? So that's why this lone pair can be very easily donated to the electron deficient compound. Hence all amines are basic in nature. First is your triethylamine, second is your APCO. The full form of the APCO is aza bicyclooctane, and third one is the DAPCO, diaza bicyclooctane, right? And this nitrogen is basically connected with the 3-ethyl group. So this nitrogen is quite heavily crowded. So there is a great deal of steric hindrance which is present on this particular nitrogen atom. That's why it is almost impossible for the electron deficient species to reach to this nitrogen to accept the lone pair. That's why this triethylamine is the least basic in this case, right? This compound is the APCO as a bicyclooctane. In this compound you can see this is your carbon group, right? Kind of a alkyl group. This will push the electron density onto this nitrogen atom due to the plus I effect, and due to this plus I effect, this nitrogen would be very highly electron rich, and electron richness directly increases the basicity of this compound. So this is basic in nature. This is the first factor, and this is not the only factor. The most important factor is that this nitrogen is quite readily available for the electron deficient compound. Electron deficient compound can very easily reach to this particular nitrogen to accept the electron pair. Why? Because this bicyclo structure it's a very rigid structure, and due to this rigidity the steric hindrance quite low in this case, and any species can come here, any electron deficient species can come here to accept the electron pair. This is the second factor. So the two factors are responsible. First is the plus I effect of this alkyl group, and second is the rigid structure which makes this nitrogen more accessible to the electron deficient compound. Now this is the third one. Though these carbons are there, the plus I effect they are operating, but you can see here both the two nitrogens are there, but these two nitrogen also exhibit the minus I effect. So minus I effect of this nitrogen will operate onto this nitrogen atom, and the minus I effect of this nitrogen will operate onto this nitrogen atom, making these two nitrogens electron deficient. So these two nitrogens are not that electron rich compared to this APCO nitrogen. So it is less basic, right? A is basically your least basic. After that your C is more basic, and then your B is the most basic. So this is the correct order of the basicity